In today's lesson, we were doing section 8.1, midpoint distance formulas. We will be using the midpoint and the distance formulas to find the distance between 2 points and the midpoint between 2 points. This is the distance formula. And x1, y1 represents one endpoint of a segment. x2, y2 represents a second endpoint of a segment. Notice the distance formula involves subtraction, and remember, subtraction is not commutative, so the order in which you plug the values in does matter. Let's see an example of the distance formula being used. We're going to find the distance between -3, 4 and 6, -11. My suggestion is that you start by labeling a point, point 1 or point 2. Once we have the points labeled as point 1 and point 2, now you're able just to substitute those values in for x1, y1, x2, y2 into the distance formula. There's the substitutions. You have your x1, x2, y1, y2. Now it's a matter of simplifying and solving. Make sure you follow your order of operations. Be careful with subtraction of negatives. We are going to keep our answers in reduced radical form, unless the context of the problem or the directions asked differently. Take a moment to try these two problems, finding the distance between these points. We are going to look at the second example together. Pause if you need to. Take a look at these distance formulas. Okay, let's find the distance between these 2 points in the second example. First thing I'm going to do is label the points point 1 and point 2. Now that I have that done, I'm able just to substitute them into the distance formula and simplify and solve. Again, the biggest thing to watch out for is being careful about simplifying your negatives. The rest is just simplification and solving, finding your distance. In the end, I get a result of the square root of 271, which cannot be simplified. So that is our final result. Okay, let's try this one. We're going to find the value of k, so the distance between the points is 10. The points are -7, 3, and then k, 11. Let's think about this in a conceptual manner. Okay, let's use the coordinate plane. Let's approximate where -7, 3 is. The next point has to be at a y value of 11. So that means it has to be on a horizontal line at y equals 11. It has to be 10 units away, but which direction? There could be 2 directions. So you should expect 2 values of k in this result. First off, like always, I'm going to identify one point as point 1 and point 2. And next, I'm going to use my distance formula and plug in the values. The distance is 10. Now I'm going to simplify the resulting equation so that I can solve for k. We cannot simplify or factor this quadratic, so we have to square both sides and create a quadratic equation. Luckily enough, this does factor, so we can factor it. When we get two resulting K's. So we have two ordered pairs that have this distance. We have negative 13, 11, and negative 1, 11. All right, on to the midpoint formula. Midpoint formula is a little bit easier to use because the midpoint is addition. So addition is commutative. So you still have your two endpoints, point 1 and point 2, but you add them, divide them by 2 for your x's, and add the y's, divide them by 2 for your y value of your midpoint. Okay, let's see it being done for these ordered pairs, 3, 5, and negative 6, 11. Again, you use the midpoint formula. Input your x's and y's. Again, add your x's divided by 2, add your y's divided by 2, and it just turns into the location of the midpoint between those 2 points. Try this. Take a moment and please try this. The result is 5.2, 3.8. I would like you to try this example for class tomorrow, and we will go through this in class. See if you can find the other endpoint of segment B.